criminal analysis using R Shiny. So over to you, Yuan. Pick up.
Good afternoon, everyone. Thank you for joining us. My name is Yuan Zhang. I'm a lecturer in AI Trust and Security. Today I'm going to give you a presentation on my current Seed Corn project, which is entitled Blockchain Forensics Criminal Analysis using R Shiny. So this is our research team, which brings the expertise from both industry and academia, covers the subject and areas such as the criminology, mathematics, statistics, data science, and blockchain. So a bit information about background. So blockchain has been widely adopted for its secure and decentralized nature. And cryptocurrencies as one of the main applications of blockchain has been widely used in our daily life. For example, in US, some of the shops, they accept Bitcoin to purchase something like Subway or Starbucks or anything in Microsoft. And in some universities, you can use the cryptocurrencies to pay for the tuition fees. The current market, the market capitalization has grown for the cryptocurrencies has grown from under 200 billion US dollars in 2020 to 3.4 trillion US dollars as of today. And unfortunately, this growth has been accompanied with a surge in the illicit activities from 1.7 billion US dollars in 2018 to 16.7 billion US dollars in 2024. And some notable examples including the WannaCry ransomware, which happened in 2017, which is a global cyber attack used Bitcoin as a ransom. Some hacking examples including the wormhole Ethereum hacking. So in this one, over 254 million US dollars worth of Ethereum has been stolen. And another famous case is the Ronin network hacking. So around 620 million US dollars of worth of NFT has been stolen. So all of these examples actually show the critical needs for the tools in order to combat with the blockchain-related crime. So one of the main challenges in addressing the blockchain-related crime is a lack of the database. So private companies such as the TRM lab and Chainalysis hold intensive resources. However, they are costly and not publicly available. Hence, our motivation is to bridge this gap and in creating the first comprehensive, publicly accessible blockchain crime database to analyze the cryptocurrency crime patterns. And this initiative will build a good foundation for understanding the blockchain crime evolution and also for aiding the prevention effort. So the current studies often focus on the isolated incidents or the private single event. Industry statistics reports from organizations such as Chainalysis or Elliptic often focus on the direct financial crimes only relating to those major cryptocurrencies. And for the academic research, for those by Xia and Carpentier, they have explored the cryptocurrency abuses and also the DeFi crime landscapes. However, a comprehensive longitudinal approach to address these blockchain crime over the whole period still remains missing. So here are a list of objectives we are going to build in our project. We're going to develop AI tools for automated web scraping from online resources and create the first live database of blockchain crimes. And based on the database, we're going to deliver the first comprehensive analysis of the evolution of blockchain crime. And in the end, we're going to embed all the analysis and the data realizations into our interactive dashboard using the R-Shiny for the real-time realization and in-depth analysis for the blockchain crime. So this flow chart shows the pipeline of our project. So we have 4 different phases. For the extract phase, we're going to focus on the data collection. And for the transform stage, we're going to focus on the data pre-processing. And then after that, we're going to feed our data into this database. And further analysis, such as the data realizations or statistical analysis, will feed into this R-Shiny. So we're going to collect both unstructured data and also structured data. For the unstructured data, the information was extracted manually and also used a combination approach through the web scraping and large language model. And for the structured data, information was mainly through the web scraping from the existing data tables. And the data collected covers all the news articles published from 2010 to 2024. So here is a list of the primary data sources being used for our project, including the Cointelegraph, CoinDesk, local news sites, CDTS News, and so on. So in this picture, you can see this is the original format before we did any extraction. Additionally, we also managed to identify some reliable secondary data sources, including the Comparitech and also DeFi Racket. As you can see in the table here, they have already been implemented for the cost structure in the table with the crime date, crime type, and also company name, platform type, and also the amount stolen. So with all these details. So following with the similar structures, we have defined a list of data variables that we want to pull out from the unstructured text, such as the crime date, crime type, the cryptocurrency and the blockchain got involved, the value got stolen, and also those company and entities. For the data, sorry, it's just my own problem. For the data pre-processing stage, it will involve removing the duplicates of the blockchain crime record and also standardizing the crime type and also the crime date. It also involved abbreviating all the blockchain names for consistency and also converting different currencies into US dollars. So to process and analyze the unstructured data, we have utilized the large language models, and through the named entity recognitions, we managed to pull out the structured data from the unstructured text. And we evaluate the performance of large language models with the manual checks, and currently the accuracy score is around 80, and we are still working on it to improve the accuracy and the scalability in the future. So what is the progress so far? So based on the methodology in the previous section, we have created a comprehensive database containing over 5,000 unique blockchain crimes across from 2010 to 2024, with the details such as the crime date, crime type, amount involved, blockchain platform and cryptocurrencies involved, and also entities involved, and so on. So this database has acted as a significant milestone to be the foundation for the further analysis. So based on the database we've created, so we have generated many data realizations which will be feed into our Shiny later on. So as you can see, these two plots actually show the prime categories. So on the left-hand side is a word cloud plot, which shows the most frequently occurred prime type. So we can see honeypot and rugpole has stand out. A similar results has been shown in the bubble chart here with the relative frequency. So in our Shiny app, we have also created this flow charts to explain the mechanism of different prime type in order to fulfill the audiences and users from different backgrounds. So here, because honeypot and rugpole has stand out, so I just use them as an example. So for this one is a flow chart to show how does a honeypot prime work. So attackers normally deploys malicious contract. And once the victims start to send the funds to this contract, and these funds will automatically move back to the attacker's wallet, and the contract will block any further withdrawals. So this is the typical honeypot crime, and I also list real-life examples here, which is the Squid Game token, 3.4 million US dollars worth has been stolen. So this is another example for rugpole with two real-life examples. So as I said, these will be embedded in the Shiny app later on as well. So these are the massive trends for blockchain crime. On the left-hand side, we can see that the total amount stolen peaks in April time, so which potentially shows that high-scale incidences happens during April. And on the right-hand side, it shows we can see that for the crime frequency reached the highest during April and May time. So these kind indicates that April or May might be a high-risk period for the cryptocurrency crime happen. So we also generate this stacked bar plot. It shows the frequency trends of the top 10 crime categories over the years, and we can see that the crime frequency increase have a trend of increasing over year by year, and it reached the highest in 2021, where we can see that the honeypot and rugpole dominate the market among all other type of crimes. And on the right-hand side, it shows the crime categories with total counts and yearly trends. So for this one, which give you the clear frequencies for different type of crimes, and also show you how do they evolve over the time. So this is another example using the tree map to show the major crime categories over the years. So we can see that in 2021, honeypot has the most frequency among all those other crime types. However, in 2022 and 2023, rugpole crime has dominated the market among those other type of crime. This is another tree map to show the total amount stolen by category over the years. We can see that around 2021 to 2022, so the exploit rugpole has significant financial losses among those other type of crime. So we also did the data realizations across different blockchains over the years. From the picture, we can see that the Binance Smart Chains and Ethereum have the highest frequencies, which can indicate that the additional security measures might be needed for this platform to enhance the security. So we haven't got the Shiny app ready, but we having all these analysis and data realization ready. So this is the preview of our Shiny app, so which will be user-friendly interactive dashboard where users can interact with the data, explore the data visualizations, and also gain the real-time insights. So this will be a valuable resources for both researchers and also the law enforcement. So here is our future work. So we're gonna enhancing the AI models for the improvement of accuracy and the scalability. We're also going to incorporate the qualitative analysis, including the interviews and the surveys, and use the qualitative results to back up with our quantitative results. And we will continue to refine the R-Shining app by integrating both qualitative and quantitative analysis. And in terms of the knowledge sharing, we're going to share the knowledge through the publications and also conferences. And we're going to use the fundings to host a workshop with different stakeholders to gain additional insight. Thank you very much for your attention.
Thank you, Yuan. So we have a few minutes for questions. If anybody would like to pose a question. Emma?
So fantastic work, really, really interesting. I'm fascinated by that spike in 2021. Do you think that's an example of a kind of crime harvest? You know, the idea that criminals can take advantage of opportunities before the defenders have a chance to catch up?
Yeah.
And if so, is there any way you could build in something around defence measures or security measures that evolve over time into your database to try and look at the interaction between the two?
Yes, definitely. Like for the work we've got so far, it's definitely the first step to have the overview of the data. And once we can find out more about the reasons, like why that has happened, definitely we will bring in the further analysis in terms of the prevention or regulation or things like that. Yeah. Thank you.
And I think from my side and my involvement in the project, I think it'd be good to do some more script analysis of some of these behaviours. That is, you know, a method that we use in criminology is to deconstruct the commissioning process of the crime. That is, what are the stages or steps you have to go through to accomplish your criminal behaviour. So I think integrating some of that qualitative insight into the scripts with this kind of larger data set will hopefully enhance the project when I have the time to do it. So you're busy when you're director
so
of the centre, you know.
Future work,
future work as well. So, any other questions? Sorry, yeah, we have.
Yeah, it's just how do you compare or integrate the structured data and unstructured data? Are they kind of play the same weight, have the same weight, or they actually contribute to different attributes?
Yeah, definitely. Yeah, so I'm just quickly go back to the unstructured. So for the I'm just sorry, way too much over. Yeah, so this is the unstructured text. Is mainly based on the news, so it can capture all different type of crimes. However, like for the secondary data sources we've got for the comparative and D5, it's specifically focused on the D5. Like these specific DeFi hackings, yeah.
Well, yeah, what I'm thinking is kind of structured data. You know, maybe you identify, you can put in the category.
Yeah.
But the criminals or hackers always kind of emerge and further develop. That will.
How to overcome?
Yes, how we're going to take the most advanced or developed.
Yeah, I understand your point. It's actually very challenging and also time-consuming tasks. That's why I mentioned in the future works we're gonna to like enhance the AI tools. That is one point, and also involve the qualitative analysis as well, where we're gonna interview and having the surveys with different stakeholders. Because at the moment it's based on the news. But some of the crime incidents is actually not disclosive. It's only inside, like not public. So that will, the qualitative results will definitely back up and provide the additional insights to our research. Yeah, does that answer your question?
Yeah, I think it's how long does it take to standardize the identification?
I say very
information?
long, couple of months. And with many teammates, like we also get students involved to look into, to identify all these reliable resources. Yeah, yeah.
We'll come back to you in a few minutes' time. Well, in the interest of time, we better leave it there. I know there were some more questions, so maybe we can have those afterwards in the networking event. Thank you again, Yuan.
Thank you.
Thank you.